and connect H prime and I prime. You have your brand new quadrilateral. Now, a couple things we need to kind of talk about before we move on to the next example. First of all, this is your pre-image. This is your original. This is the pre-image before you slide, before you do anything, before you translate it. And then once you translate it, you slide it up and to the right. This is going to be your image. Image. Perfect. Now, I'd like you to kind of down here find some space. Could you go ahead and put G, H, I, J, and then give a nice little space right here, and then put G prime, H prime, I prime, J prime. Now, the one thing that all of us need to be very, very aware of is that your pre-image and your image are exactly the same size. It's the same thing. They're equal. Even if you just kind of look at them, just from my notes, maybe yours looks the same. This original image and this new image, they kind of look exactly the same. They're congruent, everybody. Okay, for some reason, when you translate something, it doesn't change in size. It doesn't get bigger. It doesn't get smaller. It stays the exact same thing. Let's go back to 1970s disco girl right here. When you slide her down to the right, she's the same person. She doesn't get bigger. She doesn't get smaller. She's the same person. So that's the one big thing that you need to be aware of. When you slide something, it stays the same. And you guys can all see it's roughly the same thing. Shade that in. Perfect. You got a couple of these in your homework tonight, not many. Once again, draw your original figure in the book. Try to copy it down from the book the best you can, and then try to get the distance the same in the book with the translation vector. You might want to get a ruler out and just measure, just so you're all aware of how far you're moving an image. You know, for me it was 6.7 centimeters. For you it's going to be a little different. But get a ruler out and work with that. All right. I'm going to flip 2 pages because this permanent marker bleeding through the paper is driving me nuts. Example 2. All right. Let's go ahead and graph triangle TUV. Let's go to an XY axis, everybody, with vertices T, -1, -4. U, 5, -5, and we need one more point. Come on. V is 5, -5. And what did I do wrong? Yep, I screwed up. Go back to U. It's not a Mr. Kosal lesson if there isn't at least one mistake. U is 6.2. Let's change that one, everybody. -1, -4. Looking at my notes right now. Yep. U is 6.2. V is 5, -5. Perfect. Almost done. Along the vector, -3, 2. Now these aren't parentheses. These aren't even brackets. It's kind of like a less than sign and a greater than sign. The book uses this to distinguish a vector. Folks, this is a vector. I'll show you what that looks like in just a sec, but that's a vector. Alright, graph the triangle with those vertices along that vector. Alright, let's get started. I'm going to draw an XY axis. If you have graph paper, go ahead and use that. But I'm just going to create my own XY axis. Alright, my points. Well, you know, I'm kind of seeing that the biggest number is 6 and the smallest number is -5, so do we need to go out in 6 on all points? You'll see in just a second. Actually, I am going to go out 6, but give yourself just a little bit of room for a little bit of an error. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Cool. Alright, go ahead and graph that triangle. -1, -4. We'll put T right there. And U is 6.2. 1, 2, 3, 4, 5, 6. Up 2. Big fat point. and then V. Where are you, V? 5, negative 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Right there. Okay. Gonna connect real quick. See a triangle, and then we're going to slide it. Slide to the left. Slide to the right. Everybody clap your hands. Anybody actually clapping in their houses? Like you try to watch this video and you just start clapping and your parents walk by your open bedroom, they're like, what are you doing? No? Not at all? Okay. Alright, let's shake this while you guys are catching up. Alright, we got a triangle. There's triangle TUV, and we are going to translate it along the vector -3, 2. Alright, we are going to slide every single one of the points, very similar to the last problem that we just did. Let's start off by sliding point T. Now, as you can see, I don't have a physical vector here. I don't have an arrow pointing up into the right or down into the left or up that way or down that. I don't have a vector. I don't have an arrow pointing us where we are going. This tells us exactly where we are going. So what we're going to do is at this point, which is -1, -4, we are going to, this is just like graphing a point. X coordinate, Y coordinate. This first value is the side-to-side motion, and the second value, kind of like the Y coordinate, is the up and down motion. So from point T, which we already graphed, we are going to go 1, 2, 3 to the left, because it's negative, and we're going to go 2 up. 1, 2. Make a point right there. That's T prime. So what we just did is, and I'm actually going to have you go ahead and connect T with T prime. Start at T, go to T prime. That is the vector, everybody, of -3, 2. We are going 3 to the left, and we're going 2 up. That's the vector -3, 2. Notice how it has a direction. It's going up and to the left. And we have a distance. It's about that big. Let's do the same thing for the other ones, folks. Let's translate, let's slide point V. I'm going to go, graph paper is so much easier. 1, 2, if you have graph paper, you're smarter than me. 1, 2, 3 to the left, up 1, up 2. Make a big fat point. Yep. Yeah, see, this is why graph paper makes more sense. These are both going in the same direction, but it kind of looks like this second arrow is just a little bit bigger than this first arrow. Graph paper, it should be the same, but I'm going to have to live with that, everybody. All right, there's V prime. And then last one, let's take U and go 1, 2, 3, and up 1, 2, big fat point, U prime. These should all be exactly the same distance, exactly the same direction. They look pretty alright. I'm happy with that. And connect them. You should have a brand new triangle. It should be the exact same triangle. Here, let's shade that in. Kind of looks like a three-dimensional figure, doesn't it? Original. There's your pre-image. There's your PI. And this is your eye, if you can see that little eye right there. But that's it, folks. We're doing some graphing today in our homework. That is it. Graph this triangle, slide it in that direction. Perfect. Example 3. Let's make this the last example, everybody. We're going to graph the figure penta, which is going to be a pentagon. P is going to be 1, 0. E is 2, 2. Make sure I get this right this time. N is 4, 1. T is -4. Oh gosh, there it is, there it is. I tried. I failed. T is 4, -1. And last but not least, A is 2, -2. And then I gotta give you a vector. We're gonna graph that along the vector. -5, -1. Alright, let's go a little faster on this one. This is the exact same thing as this one. See if you can do it by yourself. Pause it if you need to. Fast forward if you need to. Get this in your notes. Don't just not do this. Please, please. Stay with me. 1, 2, 3, 4, 5, 6. 1, 3, 4, 5, 6. Alright. Over 1 up 0. P. Over 2 up 2. E. Over 4 up 1. 1, 2, 3, 4. N. Over 4 down 1. T. And then 2, negative 2. A. Penta. Yeah, it looks like a, I mean, I was going to say it looks like a pentagon. If it has 5 sides, 5 vertices, it's a pentagon. And if it's a closed figure, it's a pentagon. This is not a hexagon. Hexagon has 6 sides. Pentagon has 5. Alright, there it is. Let's translate it along the vector -5, -1. So pick any point. I'm going to start with A. I need to slide it 5 to the left. It's either left or right, folks. It's negative if we're going left. It's positive if we're going right. Same thing. Up and down is the next coordinate. Positive, you're going up. Negative, you're going down. So I need to go 5 to the left. I need to go 1 down. 1, 2, 3, 4, 5. 1 down. Big fat point. A prime. 1, 2, 3, 4, 5. 1 down. T prime. 1, 2, 3, 4, 5. 1 down. N prime. 1, 2, 3, 4, 5. 1 down. E prime. 1, 2, 3, 4, 5. 1 down. P prime. B. B. Nothing to it, folks. Pretty simple. Oh, graph paper's so much better. So much better, so much better. Does it even look the same, folks? Not really. This one looks like it shrunk as it slid. Should be the same. They should be exactly congruent. It's just the fact that I'm not using graph paper and my increments are not equally spaced, so that's why it's going to make it look all goofy. That's it, folks. We're drawing some graphs tonight. Drawing some graphs. Your homework can be found on page, make sure I get this to you right, page 635. Let's hit problems. 1, 2, 4, 5, 8, 12, 17, 18, and 19. Graph paper will help. A ruler, a straight edge, that will definitely help. And folks, we'll see you next time.